Now, on the checklist, everyone pull your checklist out. It does say 2D4, but that's a typo. That's supposed to say 2D.1. Okay, so that's what ties in here. We're not doing 2D4, we're doing 2D1. Now, we are jumping around a lot here. The textbook is a bit disordered, and there is a what we call method to our madness. That hopefully what we're doing, you're going to see the relationship between the things that we're doing. Although today's perhaps is a little bit disjointed, the other ones are pretty spot on. We saw the other day when we were completing the square, then we followed up by graphing by completing the square. So that was the relationship there. During our next lesson, it will be about the discriminant, the relationship between discriminant and graph. So this is a skill we've done before. So it's important, Sam, Alyssa, that we know how to do this. So can you pay attention up here, please? You can resume your work in a moment. We're sketching graphs of quadratics. So you could just go, just crunch that in my calculator, and that would be a way to check your answer. But we're going to show you how we can do this just using a mathematical process and then drawing some lines through some points. So the first thing we need to find is the axis intercepts. Okay, so x-intercepts occur when y is 0. So that means x plus 2 times x take 3 equals 0. That's the equation we're solving. We can see the solutions just by applying the null factor law. X is minus 2 or x is 3. They are the x-intercepts. If you put these numbers into this equation, it's going to make it equal 0. Okay, that's what we need. We've got the x-intercepts. Then we've got the y-intercept occurs when x is 0. So to find the y-intercept, we're going to put the number 0 everywhere there's an x. So we'll have y equals 0 plus 2 times 0 take 3. The y-intercept is minus 6. And we've got all of the information we could possibly need to put it on a graph. So Cartesian plane, we've got minus 2 and positive 3, and a y-intercept of minus 6. Alright, so it's going to look like that. Now the other thing we mentioned briefly yesterday is that the axis of symmetry is going to occur exactly halfway between them. Alright, the axis of symmetry, that's the line about which it's symmetrical. So this y-intercept is not going to be your lowest point. The lowest point, the minimum point, occurs exactly halfway between minus 2 and 3. So that's going to be at 0.5. Okay. Alright, this one up here, identify the x-intercepts, so we're going to make this equal to 0. Okay, so we've got a bit going on here, because we've got this minus 2 out the front. So the first thing I'm going to say is, well, if we're trying to solve this equation, we can just divide both sides by minus 2, alright? So 0 divided by minus 2 is just 0. So it still maintains. You can just get rid of that constant. You don't even need to worry about it. And then you're just solving these. This solution is going to be x is minus 1. Or this solution isn't immediately apparent, so we might need to process it a little bit. So we've got 3x take 2 is 0, and we're solving that equation. 3x is 2, x is 2 on 3. Alright, so if you can't see it straight away, you just need to say what's going to make that bracket equal 0? Well, it's when this is 0, and then we process that. X is 2/3. So what that means, okay, these are our roots. If you put these into this equation, it's going to make it equal 0. So we've found our x-intercepts. Let's find the y-intercept. The y-intercept occurs when x is 0. So same equation. Now this time we can't leave the 2 out. We need to have the 2 there because it's part of the initial equation. We're putting 0 into the initial equation. So minus 2 times 0 plus 1 times 3 times 0 take 2. Now I'm putting everything up there just to be thorough, alright? But you might be able to look at that and just go straight to this step. Like that, and then an answer. So we've got minus 2 times minus 2, positive 4 for our y-intercept. The other thing I want to point out here, alright, is this a value out the front. Okay, so whenever we have a thing out the front, and here it's negative. Alright, remember we said if a is positive, it's going to be a happy face, and if a is negative, it's going to be a sad face. It's negative. So already that's going to tell us about the shape, but you don't even need to know that. if you're going to plot these points on the Cartesian plane, then you are restricted by the shape. It has to go through those points. I'll show you what I mean. Here's our Cartesian plane. We've got x-intercepts of -1, so that'll be about, let's make it a big scale, and then 2/3 will be about there. 2/3 is 0.6, and it's positive. And we have a y-intercept of 4, all right? So that means it has to have this shape, okay? It can't open downwards because it has to pass through that point. Our y-intercept is dictating which way it's facing. So if we're not sure what's going on there, that's okay, because we just plot the points, graph them. Okay, over here we're just doing the opposite. We're starting with the graph and generating the equation. So, first thing we need to do, identify the roots. Alright, so I like to write it up like this. Y equals A times x take P times x take Q. Remember, we've used P and Q as the roots. The root here is -3, and the root here is +1. So we're going to have x take -3, x take +1. Okay, let's simplify that a little bit. So we've got y equals A times x plus 3 times x take 1. We need to have that A out the front, because the roots are fine, but it could be stretched, could have that sort of vertical dilation. So we need to find this value of A. Alright, and lucky we're given this point here. We could be given any coordinate, we just need to use one other piece of information to find it. So this coordinate here is when x is 0, y is 3. Alright? We might even have another point. There might be another point here. It might be when x is -1, y is 4. Alright? That might be another point that you could substitute in. This is the one that we're given. Okay, when x is 0, y is 3. So let's put that information into our function here. Y is 3 and x is 0. So we're going to have 3 times -1. Okay. Divide both sides by -3 to get A by itself. And you've got A is -1. Alright, yeah, -3 there is going to cancel. And here 3 divided by -3 is -1. So that means this quadratic is -1 times x plus 3 times x take 1. Now we don't generally put the 1 there. Okay, that 1 is sort of obsolete. And so instead what we'll do is we just leave it as a negative. We're saying it's this quadratic, but it's negative. It's facing the other one. So if you see that there, it means the value of A is -1. So this is 2D.1. All right, and that's all we're going to do today. It's a lot. Yep, we've gone through a lot, but I think a lot of it is revision as well. So see how we go? Let's get into that.